Okay, students, this is the part of the video where we are discussing the sufficient part in the Cauchy's general principle of convergence. In the Cauchy's general principle of convergence, in this theorem, we are proving the sufficient part. Sufficient part means we are assuming the condition, right? The condition is that for given epsilon greater than 0, there exists a positive integer m for which modulus Sn plus p minus Sn is less than epsilon for all n greater than or equal to m and p greater than or equal to 1. P greater than or equal to 1. So this is a condition we are assuming. With the help of this condition, we are proving that sequence Sn is converging to the limit L. P implies Q. This we have to prove. Okay. First starting nodi. Epsilon is a positive value. You take a particular value of epsilon. Take epsilon is equal to 1. Right? For epsilon is equal to 1, you are choosing epsilon as 1. You take a m value as m naught. There exists a positive integer m naught. M value is m naught. Such that mod Sn plus p minus Sn conditionally less than epsilon anta ideyalla. You are taking epsilon equal to 1. Okay. For all n greater than or equal to m naught ಅಂತ choose ಮಾಡಿದಿರಿ ನೀವು. And also you are choosing p greater than or equal to 1 by hypothesis. ಆಯ್ತಾ? So first step ಅಲ್ಲಿ ಏನು? Assume the condition. This condition is assumed. That is mod Sn plus p minus Sn less than epsilon for all n greater than or equal to m and p greater than or equal to 1 is assumed. Next, take epsilon is equal to 1. Take epsilon equal to 1. And fix a m value m naught for which mod Sn plus p minus Sn is less than epsilon ಅಂದರೆ 1 ಇಲ್ಲಿ for all n greater than or equal to m naught and p greater than or equal to 1. ಇಲ್ಲಿ ಆ್ಯಂಡ್ ಅಂತ ಇರುವಲ್ಲಿ ನೀವು ಈ ಸಿಂಬಲ್ ಬೇಕಾದರೆ ಯೂಸ್ ಮಾಡ್ಬೋದು ನೋಡಿ, ಲೈಕ್ ದಿಸ್. ಓಕೆ, n greater than or equal to m and p greater than or equal to 1 ಅಂತ ಇರುವಲ್ಲಿ n greater than or equal to m ಆ್ಯಂಡಿಗೆ ಇದನ್ನು ಬರಿಬೋದು and p greater than or equal to 1. This symbol you may use or may not use, but author is using this symbol, right? You can replace this symbol by an ampersand. Okay, ಹೇಗೆ ಬೇಕಾದ್ರೂ ಮಾಡ್ಬೋದು, ಅಡ್ಡಿಲ್ಲ. ನೋಡಿ, ಇಲ್ಲಿ ಆಪ್ಸಿಲಾನ್ ವ್ಯಾಲ್ಯೂ ಚೂಸ್ ಮಾಡಿದ ಹಾಗೆ ಇಲ್ಲಿ ಎನ್ ವ್ಯಾಲ್ಯೂ ಉಂಟಲ್ಲ, ಈ ಕಂಡೀಷನಲ್ಲಿ ಎನ್ ವ್ಯಾಲ್ಯೂ ಚೂಸ್ ಮಾಡಿ ಎನ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಎಮ್ ನಾಟ್ ಅಂತ ತಗೊಳ್ಳಿ. ಫಾರ್ ಎನ್ ಈಕ್ವಲ್ ಟು ಎಮ್ ನಾಟ್ ವಾಟ್ ಹ್ಯಾಪನ್ಸ್ ಟು ದಿಸ್ ಅಂತ, ಇಟ್ ಈಸ್ modulus the difference. You are putting n equal to m naught stay. N equal to m naught. It is less than 1. Again, as we have discussed earlier, what do you mean by saying that mod x less than or equal to a? Or less than a. Mod x less than a andre x lies between minus a and plus a. X lies between minus a and plus a. Mod x andre plus or minus x. Modulus less than a andre this value, e value untalla, modulus something, this something lies between minus 1 and plus 1 for all p greater than or equal to 1. ಇದು ನಿಮ್ಮ ಕಂಡೀಷನ್ ಇಂದಲೇ ಕಂಟಿನ್ಯೂ ಆಗ್ತಾ ಬರ್ತದೆ ಇದು. ಓಕೆ, ಮಾಡ್ಯುಲಸ್ ಲೆಸ್ ದ್ಯಾನ್ 1 ಅಂದರೆ ದ ವ್ಯಾಲ್ಯೂ ಲೈಸ್ ಬಿಟ್ವೀನ್ minus 1 and plus 1. ನೆಕ್ಸ್ಟ್ ಇಲ್ಲಿ ಮೈನಸ್ ಎಸ್ ಎಮ್ ನಾಟ್ ಉಂಟು. ಈ ಎಸ್ ಎಮ್ ನಾಟನ್ನು ಆ್ಯಡ್ ಮಾಡಿ, ಆ್ಯಡ್ ಎಸ್ ಎಮ್ ನಾಟ್ ಆನ್ ಐದರ್ ಸೈಡ್. ಆಗ ಇಲ್ಲಿ ಎಸ್ ಎಮ್ ನಾಟ್ minus 1 ಬಂತು, ಇಲ್ಲಿ ಎಸ್ ಎಮ್ ನಾಟ್ plus 1 ಬಂತು, ಇಲ್ಲಿ ಎಸ್ ಎಮ್ ನಾಟ್ ಪ್ಲಸ್ ಪಿ ಉಂಟು. ಓಕೆ, ಸೊ ಇಲ್ಲಿ ನಾವು ಬೌಂಡೆಡ್ ಅಂತ ಪ್ರೂವ್ ಮಾಡೋದು ನಮ್ಮ ಫಸ್ಟ್ ವರ್ಕ್. ಸೀಕ್ವೆನ್ಸ್ ಇಸ್ ಬೌಂಡೆಡ್. ಯು ಟೇಕ್ ಸ್ಮಾಲ್ ಜಿ ಆ್ಯಸ್ ಮಿನಿಮಮ್ ಆಫ್, ನೋಡಿ, ಫಾರ್ ಆಲ್ ಎನ್ ಗ್ರೇಟರ್ ದೆನ್ ಆರ್ ಈಕ್ವಲ್ ಟು ಎಮ್ ನಾಟ್ ಅಲ್ಲ, ಫಾರ್ ಆಲ್ ಎನ್ ಗ್ರೇಟರ್ ದೆನ್ ಆರ್ ಈಕ್ವಲ್ ಟು ಎಮ್ ನಾಟ್ ಅಂದರೆ ಫಸ್ಟ್ ಎಮ್ ನಾಟ್ ಮೈನಸ್ 1 ವ್ಯಾಲ್ಯೂ ತಗೊಳ್ಳಿ. ಇದರ ಮೊದಲಿನ ಸ್ಟೆಪ್ ಬನ್ನಿ, ಎಮ್ ನಾಟ್ ಮೈನಸ್ 1 ಇಷ್ಟು ವ್ಯಾಲ್ಯೂನ ನೀವು ಹೊರಗೆ ಇಡ್ಬೋದು. After m naught you are having this inequality existing. So first m naught minus 1 values, m naught in the ಮೊದಲಿನ values, integers, s1, s2, etc. sm naught minus 1 which are actually outside this interval, and the one you are finding on the left sm naught minus 1 ಅದನ್ನು ಕೂಡ ಇಲ್ಲಿ ಹಾಕಿದ್ದೇವೆ. ಎಸ್ ಎಮ್ ನಾಟ್ ಮೈನಸ್ 1 ಅಂದರೆ ಇದಕ್ಕಿಂತ ಚಿಕ್ಕದಲ್ವಾ, ಎಸ್ ಎಮ್ ನಾಟ್ ಮೈನಸ್ 1, ಎಸ್ ಎಮ್ ನಾಟ್ ಮೈನಸ್ 1 ಮತ್ತು ಫಸ್ಟ್ ಎಮ್ ನಾಟ್ ಮೈನಸ್ 1 ವ್ಯಾಲ್ಯೂ ಇದರಲ್ಲಿ ಯಾವುದು ಲೀಸ್ಟ್ ಉಂಟು ಇಷ್ಟು ವ್ಯಾಲ್ಯೂಸಲ್ಲಿ ಯಾವುದು ಲೀಸ್ಟ್ ಉಂಟು, ಮಿನಿಮಮ್ ಉಂಟು, ಅದನ್ನು ಜಿ ಅಂತ ತಗೊಳ್ಳಿ. ಕ್ಯಾಪಿಟಲ್ ಜಿ ಅಂದರೆ ಮ್ಯಾಕ್ಸಿಮಮ್ ಆಫ್, ಅಂದರೆ ರೈಟಲ್ಲಿ ಬರಬೇಕು ವ್ಯಾಲ್ಯೂ. ಈಗ ರೈಟಲ್ಲಿ ಒಂದು ವ್ಯಾಲ್ಯೂ ಇಲ್ಲಿ ಉಂಟು SM0+1. ಅದರ್ ವ್ಯಾಲ್ಯೂ ಅಂದರೆ ನೀವು ಎಕ್ಸ್ಕ್ಲೂಡ್ ಮಾಡಿದ ವ್ಯಾಲ್ಯೂಸ್ ಉಂಟಲ್ಲ, ದ ಫಸ್ಟ್ M0-1 ವ್ಯಾಲ್ಯೂಸ್ S1 S2 SM0-1, ಆಮೇಲೆ ಇಲ್ಲಿ ರೈಟಲ್ಲಿ ಬರುವ ವ್ಯಾಲ್ಯೂ SM0+1. ಇದಿಷ್ಟು ವ್ಯಾಲ್ಯೂಸಲ್ಲಿ ಯಾವುದು ಲಾರ್ಜರ್ ಉಂಟು, ಮ್ಯಾಕ್ಸಿಮಮ್ ಉಂಟು, ಯು ಕಾಲ್ ಇಟ್ as ಕ್ಯಾಪಿಟಲ್ ಜಿ. ಕ್ಯಾಪಿಟಲ್ ಜಿ ಈಸ್ ಮ್ಯಾಕ್ಸಿಮಮ್ ಆಫ್ ದಿಸ್, ಸ್ಮಾಲ್ ಜಿ ಈಸ್ ಮಿನಿಮಮ್ ಆಫ್ ದಿಸ್. ಸೊ ಸ್ಮಾಲ್ ಜಿ ಲೈಸ್ ಟು ದ ಲೆಫ್ಟ್, capital G lies to the right. So your terms of the sequence will be between small g and capital G. Small g and capital G. Okay. So sequence is bounded. Sequence bounded idre by Bolzano-Weierstrass theorem. Bolzano-Weierstrass theorem says that every bounded sequence has a limit point. Has a limit point andre it has at least one limit point. As the sequence is bounded by Bolzano-Weierstrass theorem, it must have a limit point, say it is L. It has at least one limit point, say L. So finally, we shall show that the sequence converges to L. ಈ ಲಿಮಿಟ್ ಪಾಯಿಂಟಿಗೆ ಸೀಕ್ವೆನ್ಸ್ ಕನ್ವರ್ಜ್ ಆಗ್ತಿದೆ ಅಂತ ಹೇಳಬೇಕು ನಾವು. ಫಾರ್ ದಿಸ್ ಲಿಮಿಟ್ ಪಾಯಿಂಟ್ ದ ಸೀಕ್ವೆನ್ಸ್ SN is converging to the limit point L ಅಂತ ಹೇಳಬೇಕು ನಾವು ಈಗ. ಓಕೆ, now in order to prove that sequence is converging to L, we make use of the condition we have assumed in the beginning. But now assume ಮಾಡಿದ condition mod Sn plus p minus Sn less than epsilon ಅಂತ assume ಮಾಡಿದಿರಿ. For all n greater than or equal to m and p greater than or equal to 1. ಈಗ ಇಲ್ಲಿ ನೋಡಿ, ಇದು epsilon ಅಂದರೆ ವೆರಿ ಸ್ಮಾಲ್ ನಂಬರ್. Even if you take it epsilon by 3 here, right, no damage is caused because it is still smaller. ನಾವು ಈ ಕಂಡೀಷನಲ್ಲಿ ಏನು ಮಾಡಿದ್ದೇವೆ ಅಂದರೆ mod Sn plus p minus Sn less than epsilon by 3 for all n greater than or equal to m and p greater than or equal to 1. epsilon ಇರುವಲ್ಲಿ epsilon by 3 ತಗೊಂಡಿದ್ದೇವೆ ಫಾರ್ ದ ಸೇಕ್ ಆಫ್ ಕನ್ವೀನಿಯನ್ಸ್. ಪ್ರೂಫ್ ಕಂಫರ್ಟೇಬಲ್ ಆಗಿ ಹೋಗಬೇಕಲ್ಲ. ಇನ್ ಆರ್ಡರ್ ದ್ಯಾಟ್ ವಿ ಹ್ಯಾವ್ ಟು ಅರೈವ್ ಎಟ್ ಎ ಪ್ರಾಪರ್ ಕನ್ಕ್ಲೂಷನ್. ಇಫ್ ಯು ರೆಡ್ಯೂಸ್ ದ ಸೈಜ್ ಆಫ್ ದ epsilon, it is more convenient. You will understand that in the next steps. Okay, so in the condition you have assumed, right, instead of epsilon you take epsilon by 3. ಅದು ಒಂದು. Next, for n equal to m, particular value of n ತಗೊಳ್ಳಿ. ನೀವು ಇಲ್ಲಿ m ಇನ ರೈಟಿಗೆ ಅಂತ ಹೇಳ್ತೀರಲ್ಲ, n is greater than or equal to m ಅಂತ. n equal to m itself ತಗೊಳ್ಳಿ ನೀವು. You take n equal to m. For n equal to m ತಗೊಂಡು ಇದು m plus p ಆಯಿತು, ಮೈನಸ್ n equal to m ಅಲ್ಲ SM ಆಯಿತು. ಇಟ್ ಈಸ್ ಲೆಸ್ ದೆನ್ epsilon by 3 ಫಾರ್ ಆಲ್ p greater than or equal to 1. You are choosing n equal to m. n may be either equal to m or n may be greater than m. n equal to m ಆದರೆ this is the situation you are having. Call it as equation number 1. Okay, you have said that by Bolzano-Weierstrass theorem the sequence has a limit point L ಅಂತ. Sequence has a limit point L. Use the definition of limit point. Limit point definition ಏನು? Limit point definition ಪ್ರಕಾರ, if L is a limit point, then mod Sn minus L is less than epsilon. For given epsilon greater than 0, there exists a positive integer m for which mod Sn minus L less than epsilon for all n greater than or equal to m. So this follows by the definition of limit point. So limit point definition in the ಸಿಕ್ತು ನೋಡಿ. As L is a limit point, there exists a integer, positive integer m1 greater than m, m1 to the right of m. Take an m1 here to the right of m such that SM1 minus L is less than epsilon by 3 ತಗೊಳ್ತೇವೆ ನಾವು. epsilon ತಗೊಳ್ಳೋಲ್ಲಿ epsilon by 3, right? See, whenever you say that a sequence is having the limit L ಅಂತ ತಗೊಳ್ಳುವಾಗ, for a value to the right of m, say it is to the right of m, you are choosing m1, the sequence must be converging to L. SM1 should be converging to L, right? That is mod SM1 minus L should be less than epsilon. I will take it as epsilon by 3 ಅಷ್ಟೇ. mod SM1 minus L less than epsilon by 3. ಇದು ಸೆಕೆಂಡ್ ಕಂಡೀಷನ್ ಆಯಿತು. ಕಂಡೀಷನ್ 1, ಕಂಡೀಷನ್ 2. ನೆಕ್ಸ್ಟ್ ನೋಡಿ, m1 is a value greater than m. You are using reference number 1. Equation 1 use ಮಾಡ್ತೀರಾ. ಇಲ್ಲಿಗೆ ಸಫಿಕ್ಸ್ ನೋಡಿ m plus p. p is greater than or equal to 1 ಅಲ್ಲ. So m plus p, it is greater than m. First suffix is greater than second suffix. ಆಗ difference is less than epsilon by 3. ಇಲ್ಲಿ m1 greater than m. First suffix ಇಲ್ಲಿ ಹಾಗೆ. First suffix is greater than second suffix. ಇದು sm. First suffix is greater than second suffix. ಆಗ difference is less than epsilon by 3. So ಇಲ್ಲಿ from reference number 1, from equation number 1, or from the inequality 1, mod sm1 minus sm is less than epsilon by 3. Call it as equation number 3. So we are having reference 1, reference 2, reference 3. ಇದು ಮೂರನ್ನು ಕಂಬೈನ್ ಮಾಡಿದರೆ ನಮ್ಮ ಪ್ರೂಫ್ ಕಂಪ್ಲೀಟ್ ಆಯಿತು. ಓಕೆ, ಸೊ ಕಾನ್ವರ್ಸ್ ಪಾರ್ಟಲ್ಲಿ ನೀವು ಫಸ್ಟ್ ಸೀಕ್ವೆನ್ಸ್ ಬೌಂಡೆಡ್ ಅಂತ ಹೇಳಬೇಕು. ಆಗ ಬಾಲ್ಜಾನೋ-ವೈಸ್ಟರ್ಸ್ ಥಿಯರಮ್ ಕ್ಯಾನ್ ಬಿ ಅಪ್ಲೈಡ್. ಅಕಾರ್ಡಿಂಗ್ ಟು ದ ಥಿಯರಮ್ ಯು ವಿಲ್ ಹ್ಯಾವ್ ಎ ಲಿಮಿಟ್ ಪಾಯಿಂಟ್ ಸೇ ಎಲ್. ವಿ ಶಾಲ್ ಶೋ ದಟ್ ಸೀಕ್ವೆನ್ಸ್ ಇಸ್ ಕನ್ವರ್ಜಿಂಗ್ ಟು ಎಲ್ ಅಂತ. ಓಕೆ, ದಟ್ಸ್ ಅವರ್ ಜಾಬ್. ಸ್ಟಾರ್ಟಿಂಗ್ ಪಾಯಿಂಟಲ್ಲಿ ಸಿನ್ಸ್ ಯು ಹ್ಯಾವ್ ಅಸ್ಯೂಮಿಂಗ್ ದ ಕಂಡೀಷನ್, by the condition assumed mod Sn plus p minus Sn is less than epsilon by 3. The epsilon by 3 ಬರೆಯೋದು, there is no damages cost, there is no loss of generality for all n greater than or equal to m and p greater than or equal to 1. ಇಲ್ಲಿ n ಗೆ ಪರ್ಟಿಕ್ಯುಲರ್ ವ್ಯಾಲ್ಯೂ m ಕೊಟ್ಟಾಗ ದಿಸ್ ಇಸ್ ದ ಸಿಚುವೇಶನ್, ಕಾಲ್ ಇಟ್ ಎಸ್ 1. ಅದು ಒಂದು. ಆಮೇಲೆ as l is a limit point, you know the definition of limit point, mod Sn Sn minus l less than epsilon by 3 ಅಂತ ಬರಿತೇವೆ. ಸೊ ಯು ಆರ್ in particular you are choosing an integer m1 greater than m, any value to the right of m for which mod sm1 minus l is less than epsilon by 3. Epsilon by 3 choice is not a problem because epsilon is the smallest positive number. Epsilon by 3 is still smaller. If this value is smaller, this width is getting smaller. ಆಗ ಕನ್ವರ್ಜೆನ್ಸ್ ವಿಲ್ ಬಿ ಫಾಸ್ಟರ್. ದಿಸ್ ನೋ ಡ್ಯಾಮೇಜ್ ಕಾಸ್ಟ್ ಬೈ ಚೂಸಿಂಗ್ ಆಪ್ಷನ್ ಬೈ 3. ಇದು ಒಂದಾಯಿತು, ಇದು ಒಂದು ಎರಡಾಯಿತು. ಥರ್ಡ್ ಒನ್ ಏನಂದರೆ m1 ಇಸ್ ಗ್ರೇಟರ್ ದನ್ m ಅಲ್ವಾ. ಇಲ್ಲಿ m ಪ್ಲಸ್ p ಇಸ್ ಗ್ರೇಟರ್ ದನ್ m. ಈ ಸಫಿಕ್ಸಿಂದ ಜಾಸ್ತಿ. ಆಗ ಡಿಫರೆನ್ಸ್ ಈಸ್ ಲೆಸ್ ದ್ಯಾನ್ ಎಪ್ಸಿಲಾನ್ ಬೈ 3. ಇಲ್ಲಿ m1 ಇಸ್ ಗ್ರೇಟರ್ ದನ್ m, ಸೊ ಡಿಫರೆನ್ಸ್ ಈಸ್ ಲೆಸ್ ದ್ಯಾನ್ ಎಪ್ಸಿಲಾನ್ ಬೈ 3. ಇದು ಇಕ್ವೇಷನ್ ನಂಬರ್ 3. ಸೊ ಯು ಆರ್ ಹ್ಯಾವಿಂಗ್ ಇಕ್ವೇಷನ್ 1, 2, 3. Now we conclude our proof. We want to show that Sm plus p minus l. Sn is converging to l ಅಂತ ಪ್ರೂವ್ ಮಾಡಲಿಕ್ಕೆ ಸೀಕ್ವೆನ್ಸ್ Sn is converging to l ಅಂತ. You start with Sm plus p minus l. Okay. What you are doing ಅಂದರೆ adding and subtracting. Subtracting Sm, adding Sm. Subtracting Sm1, adding Sm1. ಈ ಒಂದು ಕೆಲಸ ನೀವು ಮಾಡಬೇಕು. ಇದು Sm ಪ್ಲಸ್ ಪಿ ಇಲ್ಲಿ ಉಂಟು, ಎಲ್ ಇಲ್ಲಿ ಉಂಟು. ಮಿಡಲಲ್ಲಿ ಸಬ್ಟ್ರಾಕ್ಟಿಂಗ್ ಆ್ಯಡಿಂಗ್ ತಗೋಬೇಕು. ಮೈನಸ್ Sm ಪ್ಲಸ್ Sm ಆ್ಯಕ್ಚುಲಿ ಕ್ಯಾನ್ಸಲ್ ಆಗುತ್ತೆ. ಮೈನಸ್ Sm1 ಪ್ಲಸ್ Sm1 ಸಬ್ಟ್ರಾಕ್ಟಿಂಗ್ ಆ್ಯಡಿಂಗ್. ಓಕೆ, ಇದು ಟ್ರಯಾಂಗಲ್ ಇನ್ಇಕ್ವಾಲಿಟಿ, ಇದು ಎಕ್ಸ್ಟೆನ್ಷನ್, ಇದು ರೈಟ್. ಈ ಥರ ಬರುತ್ತೆ. ಮಾಡ್ ಎ ಪ್ಲಸ್ ಬಿ ಪ್ಲಸ್ ಸಿ ಇದ್ದರೆ ಎ ಪ್ಲಸ್ ಬಿ ಪ್ಲಸ್ ಸಿ, it is less than or equal to mod A plus mod B plus mod C. ಹೀಗೆ ಬರುತ್ತೆ. ಇದು mod A plus B plus C less than or equal to mod A plus mod B plus mod C. Okay, but from our equation 1, 2, 3, one of the first value is less than epsilon by 3, second one also less than epsilon by 3, third one is also less than epsilon by 3. So this difference is less than epsilon by 3. This is less than epsilon by 3. The other one is also less than epsilon by 3 by using 1, 2 and 3 which I noted earlier. It is for all p greater than or equal to 1. ಈಗ ನೋಡಿ, ಲೆಫ್ಟಲ್ಲಿ ಏನುಂಟು, mod Sm plus p minus l ಉಂಟು. It is strictly less than epsilon for all p greater than or equal to 1. Okay, what is Sm plus p here? It is a value of n. It's a term value. M plus p, look here, m plus p is greater than or equal to m. It's a term value greater than or equal to m. Term value greater than or equal to m, we call it as n. right? For any n it is true, right? It is going to be true for any n which is to the right of m. So you replace m plus p by n. So n is greater than or equal to m. Replace m plus p by n, right? So that modulus Sn minus L is less than epsilon for all n greater than or equal to m. This is nothing but saying that sequence Sn is converging to L. Sequence Sn converges to L. Fine. That is, condition is sufficient. The condition which you are assuming initially, the condition you are assuming in the beginning, it is sufficient to prove that sequence is convergent. That is the meaning. The condition which you are assuming is sufficient to prove that sequence is convergent. Okay. So ಇಲ್ಲಿ ನೀವೇನು ಮಾಡಿ ಫಸ್ಟಿಗೆ ಏನು ಮಾಡಿದ್ರೆ ಬೌಂಡೆಡ್ ಅಂತ ತೋರಿಸಿದ್ರಿ, right? By choosing particular value of epsilon, particular value of n, you are proving that sequence is bounded, so that you are eligible for applying Bolzano-Weier's theorem. The theorem says that a bounded sequence has a limit point, at least one limit point, and our attempt is to show that sequence is converging to the limit point L. So you are assuming the condition first. Condition is this: with all that chosen, mod Sn plus p minus Sn less than epsilon by 3 for all n greater than or equal to m and p greater than or equal to 1. ನೀವು ಕಂಡೀಷನಲ್ಲಿ ಆಪ್ಸಿಲೋನ್ ಅಂತ ಬರ್ತಿದ್ರಿ, ಇದು ಆಪ್ಸಿಲೋನ್ ಬೈ 3 ಬರೀತಾ ಇದ್ರಿ ಅಷ್ಟೇ. ಈಗ ಇದಕ್ಕೆ ಪರ್ಟಿಕ್ಯುಲರ್ ವ್ಯಾಲ್ಯೂ ಆಫ್ ಎನ್ ಕೊಡಿ, ಎನ್ ಈಕ್ವಲ್ ಟು ಎಮ್ ಕೊಟ್ಟರೆ ಇದು ಬರುತ್ತೆ, ಒಂದಾಯಿತು. ಮತ್ತು ಸೀಕ್ವೆನ್ಸ್ ಇಸ್ ಕನ್ವರ್ಜಿಂಗ್ ಟು ಎಲ್ ಆದರೆ ಯು ಆರ್ ಏಬಲ್ ಟು ಫೈಂಡ್ ಎನ್ m1 ಟು ದ ರೈಟ್ ಆಫ್ ಎಮ್ ಫಾರ್ ವಿಚ್ ದಿಸ್ ಡಿಫರೆನ್ಸ್ ಇಸ್ ಲೆಸ್ ದ್ಯಾನ್ ಆಪ್ಸಿಲೋನ್ ಬೈ 3. 2 ಆಯಿತು. ನೆಕ್ಸ್ಟ್ m1 is greater than m. You can use your inequality 1. ಇಲ್ಲಿ m plus p is greater than m. First suffix is greater than second suffix. So the difference becomes less than epsilon by 3. ಇಲ್ಲಿ m1 is greater than m. First suffix greater than second suffix. So the difference is less than epsilon by 3 with the help of 1. So you are having 3 inequalities here, 1, 2 and 3, which we are using in the conclusion of the proof. Okay. You start with the mod Sm plus p minus L. Subtract Sm, add Sm. Subtract Sm1, add Sm1. ಇದಕ್ಕೆ ಬ್ರ್ಯಾಕೆಟ್ ಕೊಟ್ಟರೆ 3 ಗ್ರೂಪ್ ಆಯಿತು. ಇದು ಎ, ಇದು ಬಿ, ಇದು ಸಿ ಇದ್ದರೆ mod a plus b plus c less than or equal to mod a plus mod b plus mod c. Each of this is less than epsilon by 3 by reference number 1, 2 and 3. ಇದು less than epsilon by 3, ಇದು ಕೂಡ less than epsilon by 3. ಇದು 1 by 3 plus 1 by 3. It's going to be 3 by 3. 3 by 3 ಅಂದರೆ epsilon ಆಯ್ತು ಇದು. Okay. For every p greater than or equal to 1. So this difference, modulus of this difference is less than epsilon for all p greater than or equal to 1. What is m plus p? It's a value to the right of m. For any value to the right of m, this happens. So replace m plus p by n. Okay. Replace m plus p by n. You can have your own choice of m ಅಲ್ಲ. ಒಂದು ಕಡೆ m2 ತಗೊಂಡ್ರೆ ಇನ್ನೊಂದು ಕಡೆ m equal to 3 ತಗೊಳ್ಬೋದು, 4 ತಗೊಳ್ಬೋದು. You can take an arbitrary choice. Arbitrary choice you can take. So in general you can replace it by n. ಅರ್ಥ ಆಯ್ತಾ? So mod Sn minus L less than epsilon for all n greater than or equal to m. So this is nothing but saying that sequence is converging to L. So you are proving that sequence is converging to L by using the condition. This is what exactly required for us. The condition is sufficient ಅಂದರೆ condition is sufficient to establish that sequence Sn is converging to L. Okay. Necessary ಮತ್ತು sufficient. Necessary ಅಂದರೆ a sequence Sn is converging to L. In order that sequence Sn is converging to L, what is necessary? Condition is necessary. Sufficient ಅಂದರೆ it is sufficient to prove that sequence Sn is converging to L, right? Make a correction. The condition is sufficient. Sufficient ಅಂದರೆ the condition is sufficient in order to prove that sequence is converging to L. Actually there are two statements, statement 1 and statement 2. You are proving 1 implies 2 as well as 2 implies 1. If and only if ಉಂಟಲ್ಲ ಅದೇ IFF ಬರೆದ್ರೆ ಇದು if and only if ಅಂತ. If and only if ಬರಿಬೋದು ನೀವು, ಇಲ್ಲಾಂದರೆ necessary and sufficient condition ಅಂತ ಬರಿಬೋದು. Hopefully you understood this. Please go through this again Suppose you still have difficulty, doubt, if I find time, I may prepare another video for further clarification. But after you just go through this first, see that you are able to understand. In case of difficulty, please message immediately. You just tell what type of difficulty you are facing in understanding the necessary part and sufficient part. Such difficulties can be explained again either through video or phone call or explanation, written explanation, whichever you want. But it's important theorem. Take care. Thank you. Fine. Next 3 days, you are going to prepare for the topics which are covered so far till now. All the topics very in detail you have to cover, thoroughly you have to cover, and Saturday you have to write a 2-hour examination. Question paper will be sent online. Okay, you have to write 2-hour examination on Saturday. So next 3 days you have to prepare yourself for all the topics from the beginning till today. And if you have any doubts, clarification required, please ask immediately. You can do it today, do it tomorrow, day after tomorrow, till Friday. Till Friday, you can keep on. It can take your time for clarifying the doubts, right? For making yourself more comfortable in the topic, right? Whatever necessary actions required, please take it. But see that you are thorough with the topic on Friday evening, so that Saturday morning you are going to write a 2-hour test. Okay. All the best. Until we meet again. Thank you. Bye.